So in this video, it's slightly harder than the other Suvat ones that we've done, just because we're dealing with two particles or two cars for this instant. But actually it's okay once you get your head around what you need to be doing. I have underlined the bits that I thought were important, just because for me, looking at a big block of words doesn't really help me out. So I'm just going to explain why I've highlighted these bits. So the two cars A and B, we don't need to know it's two cars, we can just think of them as particles really. It's moving on the same direction on a straight horizontal road. So thinking that it's horizontal means it's going to be Suvat. We're told that at time 0 they are side by side, so that means that they're at the same point, and that point is point O. Now we're told that car A travels at a constant speed, so that means it's not increasing at all. So actually, rather than Suvat, we're going to be using the formula distance divided by time equals speed, okay? Or speed equals distance equals speed times time, whatever version you would want to use. But for car B, we're told that when it passes O, it has a speed of 20 meters per second. But it has a constant acceleration, so that means that that's the one that we're going to be using Suvat for. Okay, so for part A, we are asked to find the speed of B once it's travelled 78 meters from O. Okay, so I'm just going to start off with Suvat, so writing the letters out, and then we can fill in the parts that we know. So the distance we know is 78. His initial speed was 20, we were told that. We know the acceleration is 4. Now we're looking for V, so I'm just going to put a question mark there. So looking at our equations, the one that involves all of those would be number 4. Okay. So V squared equals U squared plus 2AS. And we just sub everything in. So V squared equals 20 squared plus 2 times 4 times 78. So that's 400, that's 625 I think. 2 times 4 times 78. Yep. 4. So V squared equals 1024. We then need to square root the answer to get what V is. So V is the square root of 124, 32. Okay, so that's the speed once he's travelled, or car B has travelled 78 metres. So part B, so we need to find the distance from O to A when B has travelled this. So to do this, we need to try and work out the distance that A has already travelled, okay? So we're going to be using distance divided by time equals speed. Now at the moment we know what the speed is because we're told that it's 30 meters per second there, but we don't know any of the other bits. Obviously we're looking for the distance, but we don't know what time it was when car B had travelled this amount of time, this amount of distance. So we need to use Suvat to then do this first. So again, Suvat, okay, everything will be the same as what we use here. It's just we'll know now that V is 32. Okay, and we're looking for that. I'm just going to call it T. So I'm going to use equation number 1, just because it's the simplest one. So V is 32, U is 20, A is 4, and we're looking for T. So take away 20. So 12 equals 40. And then we divide by 4. So T is equal to 3 seconds. So we know that it took 3 seconds for the car B to get that far. Okay, so then using this formula, so the distance that we're looking for, so distance divided by the time that we know is now 3 is equal to the speed of 30 meters per second to the minus 1. So the distance must be that times by 3, because we need to get rid of the 3 on the denominator, which is 90 meters. Okay, from O to A. Okay, so that's that bit done. Now the next part is a little bit harder as well, so you can just about see C there. We need to find the time when B overtakes A. Now for that to happen, one, the distance must be the same. Okay, but also the time needs to be the same. Okay, because they obviously have to cross at the same amount of time, and the distance must be the same as well, otherwise they wouldn't ever be able to cross. So for our car A, we're still using speed is distance over time. Now for the distance, I'm just going to call that D, and for the time I'm just going to call that T for now. Okay, so using the formula, we know what S is, we know what the speed is. It was 30. Okay, we obviously don't know the other two bits, but I will multiply on T by both sides just so that it looks more like an equation slash formula, whatever you'd like to call it. So what I'm going to actually form is simultaneous equations. So that's my equation number 1. Okay. So for the car B, similar thing, except it's a little bit harder just because we're using Suvat. So T, we're just going to call T, D for the S, so the distance or displacement. We know the parts that go here, so we know that the initial speed was 20 and we know the acceleration is 4. We can't use V as being 32 because it won't be the same distance as part A where it's 78. Okay, so looking at the formulas, the one that uses all of those, so S, U, A, and T, so it's going to be number 2. So S equals UT plus a half AT squared, and we're just going to sub it in. So S is just the letter D. V is 20, T is still T, plus a half times 4 times T squared, and then just sort of simplify it. So half times 4 would be 2. Okay, so this is my equation number 2. Now quite nicely they've both been made to be equal to D, so what I can do is I can make the other sides equal to one another. Okay, so 30t, which is this part here, must be the same as 20t plus 2t squared. And then we can solve it. So first thing is we need to make it equal to 0. So we take away 30t from both sides. Very tiny. So that's going to be 2t squared minus 10t. Then we can factorise. They've both got a 2t in common, so I can take that out. So that'll be t minus 5. You could have divided by 2 first if you wanted and then done it, because obviously if you do 0 divided by 2, it'll still be 0. So then this is telling me that for this one, t is 0, which is the first point at point O. Okay, or from this bit, t is 5. Okay, so B overtakes A at 5 seconds.